So guys, you have calculated the water demand of this building. Okay, you know the total GPM requirement is 12.8, which is the water demand, and you already know the GPMs of each section of the pipe. Now the next step is the finding of the diameter of each pipe, or you can say finding the sizes of these pipes. We will start from H to I section. Okay, forget about these green pipes. As you know, these green pipes are basically fixture supply pipe. The diameter of these fixture supply pipe already available in the International Plumbing Code. We can use International Plumbing Code table to find out the dia of these green pipes. Okay, so that's not a big deal. First of all, we need calculation for these main branches and main pipe and water service pipe. After the calculation of the diameter of these blue pipes, we can easily get the dia from the tables. But for these blue pipes, these cold water supply pipe, no data is available on in IPC. We need some mathematical calculations. Okay, now for the mathematical calculation, we have a general formula: V equals to 0.408 Q over D square. Okay, after rearranging, you can separate the value of D and find out the diameter. Here V is the water velocity, Q is the GPM that you already know. For example, if you find the diameter of HI section, you know the GPMs, G. Okay, you will put over here Q in place of Q, GPM. Q is the flow rate of water inside pipe in GPM, but you don't have the value for velocity. The value of velocity you can get from Plumbing Engineering Design Handbook Volume 2, Plumbing Systems by American Society of Plumbing Engineers, ASPE. Okay, don't get confused, I will solve it for you, but I'm just giving you an introduction that what value of velocity you can use from this handbook. For steel, 4 to 8 fps; for copper, 8 fps; for cold water, if uh, the hot water is has temperature of less than 140 degree Fahrenheit, then 2 to 3 fps; 4 to 5 fps if the temperature of water in copper pipe is greater than 140 degree Fahrenheit. For PVC pipes, in this project I have chosen PVC pipe. Okay, and for that purpose, for PVC pipes the velocity must be 4 to 6 fps; for CPVC pipes 5 fps; for polyethylene 6 to 8 fps. Okay, in my case I am taking 4.9 fps. Okay, I have to choose in between 4 to 5 fps, so I have taken 4.9 feet per second for plastic pipe, which is less than 5 fps for PVC pipe. Okay, why they have restrict us to select the higher velocities? Because if there will be high velocity in pipes, it will cause corrosion or erosion, right? And it can create huge noise which can cause disturbance for the people inside the building, and so many factors which uh, high velocity can damage the pipes. Okay, so therefore we have to follow the good engineering practice, and these velocity values are available in Plumbing Engineering Design Handbook volume 2. So you don't need to buy this book. I already provide here the velocity limitations, and I get all these values from this handbook. So in the next video I will teach you how to find out the diameter of each section, right? So before going to start from section HI, you know that we have developed the fixture unit values and GPMs for each section. As you know, we have already developed an Excel sheet. So what I did, I provide this sheet to you, don't worry about it. What I did, I write the fixture values in front of each section and GPM values from this riser diagram to avoid any confusion, because sometimes it is difficult to read the entire riser diagram. So what I did, I developed a sheet and right in front of each section, like for example HI section has one fixture value. check it from here. HI has one fixture value and GPM is 3. So what I did, I write it down over here, and then I will write the diameter of each section in front of this cell, so that it will be easy for everybody to know that what are the sizes belongs to the individual section. Okay, now as you know that I have told you this formula, now you know the value of velocity, which is 4.9 in all the cases, and individually we will find out the diameter. Now you know that calculating for the huge project, manual calculation, it is very difficult. So what I did, I have found a very good online calculator. You can use that online calculator and find out the diameter. I will provide you the link in the description. Okay. So this is pipe water velocity and minimum pipe diameter. Irrigation in the Pacific Northwest. This is a very good website. Now, what you have to do, don't use this calculator moving towards minimum pipe diameter with 5 fps velocity. Okay, you can use this. Now it uses same formula. From here you can select the unit. In our case we have GPM, and for diameter output you can select from millimeter, feet, inches, centimeter and meter. In our case we will select inches. Now open the project. HI section. Okay, we have developed the Excel sheet we will use from here. Easy for you. Okay, HI section has 3 GPM. So what will be the pipe diameter? 3 GPM. Velocity, already it assume 5 fps, not greater than 5 fps. Okay, as you know that in case of plastic pipe, PVC pipe, the velocity must be between 4 to 5 fps. Here it is written over 4 to 5. Okay, sorry, this one 4 to 6 fps, so I am taking 5 fps. You can use 4.9 in manual calculation, but as you know it is online calculator, by default it is taking 5 fps. It is also correct, not greater than 5. Okay, so it will give you, after putting 3 GPM, it will give you 0.5 inches. Come back to our sheet. Here I have, normally the pipe sizes in the market are available in fractional inches, so it is giving you 0.5 value. So you can convert from this table. 0.5 decimal inch means 1 by 2 inch, so you can write down over here 1 by 2 inches. Now moving towards GH section. GH section has 6.8 GPM. G to H has 6.8 GPM. Okay, 6.8 with 5 fps velocity, calculate 0.7 inches. 0.7 over here, 0.7 inches means 3 by 4. So write it down, 3 by 4 inches. Now, next is F to G, 7.5 GPM. Confirm from here, F to G, 7.5 GPM. Okay, 7.5 GPM. Calculate 0.8 inches. Now 0.8 inches means that there is no 0.8, because the standard value available in the market is either 0.75, 3 by 4 inches or 1 inches. So you can always select the higher value or higher size for the pipe. So I am taking 1 decimal inch, which is always equals to 1 fractional inches, because 0.8 is not available in the market. This table is as per the availability of pipe size in the market, right? 0.5 in actual practice not available in the market, so I am taking 1 inch. 1 inch. Now the next FB is also 7.5. Let's cross check from this riser diagram. F FB, F and B is 3.7 with 7.5 GPM. Okay, it is all also same. 1 inch. Now the next we have DE section with 3 GPM. First you have to cross check DE section with 3 GPM. Alright. With 3 you calculated 1 by 2. So same here. You don't need to go towards the online calculator. You already calculated for 3 GPM. For 6 CD. Okay. CD section has 6 GPM. Yes, that is true. Now moving towards the online calculator, 6 GPM with 5 FPS velocity. Remember, you can use this formula and calculate manually by using 5 FPS velocity or 4.9, but I am using this online calculator to avoid any confusion and to solve more quickly, because in actual practice you have so many sections of pipe, you have to perform your calculation as early as possible. So for that purpose you have to use this online calculator. Now for this 6 GPM, when you calculate, it is 0.75. Yes, this is available in the market. 0.75, which is equals to 3 by 4 fractional inches. 3 by 4 fractional inches. The next is 7.5. I already calculated 7.5 GPM. 1 inch pipe dia will be used, so I will write down 1 inch over here. Now the last point is AB section with 12.8 GPM, that is total demand. Okay, let's cross check from our riser diagram. We have AB section which consists of this. From here to here we have the section of water distribution pipe, and from here to here we have water service pipe. In actual, we can say that this complete section is the water service pipe. So for water service pipe, the GPM is 12.8. Let's go towards online calculator and we'll calculate the dia for water service pipe. Press calculate. 1 inch. Okay, let's check, is it available in the market? Yes, 1 inch pipe is available. For 12.8 we can also use 1.1 inch. Don't get confused that it has 7.5 GPM. I'm using 1 inch, and for 12.8 I'm also using 1 inch. Why? Because in actually 7.5 GPM requires 0.8 inch of pipe, but 0.8 is not available in the market. So that's why I took the larger size. Okay, larger size 1 inch, because 0.75 is available and 1 inch is available, so that's why I took the higher value. So this is how you can get the diameter of your water distribution and water service pipe. In the next video I will write down all the dias over here and provide you this image as well, so that you can use this riser diagram in your actual practice. Next step is to calculate the diameter or pipe size for fixture supply pipe, which is in green color. You already know that fixture supply pipe is such a pipe which connect the main branch pipe or a distribution pipe line with the fixture. Such pipe is called fixture supply pipe. Now, one fixture can be connected with one or more fixture supply pipe. In case of laboratory, you know that laboratory has two connections, for cold water and for hot water. But you know that when we started this sample project, I told you that to avoid any confusion, I am just considering cold water supply. I am not considering the hot water supply. That's why there is only one fixture supply pipe, okay, which is supplying cold water. Okay, so we will find out the diameter of these pipes. This is very easy. We don't need to find the diameter by using mathematical calculations, because the diameter of these fixture supply pipe is already given in IPC chapter number 6, table 604.5, and you can find out on page number 61 of PDF file. Okay, so this is the table from where you get the value of diameter directly. You can take the value from here and write it down in your project. So First of all, starting from the most remote fixture, which is bathtub. Bathtub is connected with one fixture supply pipe. The diameter d small equals to the size of bathtub over here is given for 60 by 32, smaller size or larger size, both are using 1 by 2 inches. Okay, so we will write down here 1 by 2, 1 by 2 inches. Done. Now moving towards this one, this section H2, water closet. For water closet, we know that we are having water closet flush tank, because for residential purpose we use flush tank water closet 3 by 8. The next we have lavatory. Lavatory 3 by 8. 3 by 8 inches. Done. Here we have lavatory again. Dia equals to 3 by 8 inches. Water closet 3 by 8. You can cross check again. Water closet flush tank 3 by 8 inches. D equals to 3 by 8 inches. Okay. Kitchen sink. The fixture supply pipe for kitchen sink. Kitchen sink 1 by 2. So this is how we have calculated all the dias of each section for water distribution pipe, for water service pipe, for fixture supply pipe. All the dias have been calculated. Now you can already transfer all the answers into this Excel sheet for to avoid any confusion. We also do for fixture supply pipe over here, so that in near future when you open this sheet you can easily read all the information without going through this riser diagram. So what I did, I have developed this sheet. I'm number of times I tell you that I will provide this sheet to you, so don't worry about this thing. You can find this sheet in the resources section. It consists of main water distribution pipe data, standard pipe size which are available in the market in decimal inches and fractional inches. And now what I did, here is the section. I noted down all the sections over here. First is I3 section, then H2, G1, E to 6 section, D to 5 section, C to C4 section. Okay, all the sections are written over here, and right in front of that I noted down the fixture type. I3 have bathtub. Cross check this. I3 has bathtub, H2 has water closet, G1 has lavatory. G1 has lavatory, H2 has water closet, same. E6 has lavatory, E6 has lavatory, D5 has water closet, C4 has kitchen sink. Now I will write down the dia of here. I3 has how much of dia? I3 1 by 2 inches. Okay, 1 by 2 of inches. Now H2 here 3 by 8 inches. 3 by 8 inches. Now G1 3 by 8 again. 3 by 8 again. E6 already again we are coming up with lavatory 3 by 8 again. Water closet above we already find out 3 by 8 over here again. Kitchen sink, let me cross check again. Here we have kitchen sink underneath the C4 section of pipe, fixture supply pipe. It will be 1 by 2 of inches. 1 by 2 of inches. So this is how you can calculate the fixture supply pipe diameters. No need for any mathematical calculation, because the table 604 minimum size of fixture supply pipes are given over here.